June 6, 1944, 6:30 a.m., Gold Beach, Normandy. American commanders watched in disbelief as British tanks emerged from the ocean itself, swimming through waves like mechanical sea creatures, while U.S. forces struggled against concrete bunkers and drowned in deep sand. Their British counterparts drove vehicles that laid their own roads, cleared minefields, threw flames at fortifications, and breached walls with a single explosive charge. The Americans had rejected these machines, called them circus acts, unnecessary complications. By noon, the cost of that decision was written in blood across Omaha Beach. This is the story of how one stubborn British officer transformed the entire concept of armored warfare, not through bigger guns or thicker armor, but by asking a question nobody else dared to ask. What if we stopped thinking about what tanks should do and started thinking about what beaches and bunkers actually required? Major General Percy Hobart didn't just modify tanks, he created an entirely new category of military engineering that solved problems everyone else thought were unsolvable. And the solutions were so bizarre, so unconventional, that his own superiors tried to retire him just to make him stop talking. But Winston Churchill had other ideas.
The Dieppe raid of August 19, 1942, should have been a footnote in military history. Instead, it became the bloodiest lesson in amphibious warfare the Allies would ever receive. 6,000 troops, mostly Canadian, assaulted the French coastal town. The plan seemed straightforward: land on beaches, seize the port, gather intelligence, withdraw. Churchill-type tanks would provide armored support. 9 hours later, 3,367 men were casualties. Not a single objective achieved. The Churchill tanks? They never made it off the beach. The heavy vehicles sank into loose shingle stones, tracks spinning uselessly. Those that did move forward encountered a 12-foot seawall they couldn't climb. German gunners in concrete pillboxes picked them apart at leisure. Engineers trying to clear beach obstacles were cut down in minutes. British and Canadian military analysts spent months dissecting the disaster. Every report arrived at the same terrifying conclusion: beach assaults against fortified positions were essentially suicide missions. The obstacles were insurmountable. Beaches presented a unique combination of engineering challenges no existing equipment could address. Soft sand and shingle that swallowed vehicles, minefields buried in approaches, massive concrete obstacles called Belgian gates and hedgehogs, bunkers with interlocking fields of fire, seawalls blocking vehicle advancement, and troops needed to cross all of these while under constant fire from elevated positions. Traditional military thinking offered no solutions. Tanks were designed to fight other tanks on solid ground. Combat engineers needed time and cover to clear obstacles, neither available during beach assaults. Naval bombardment couldn't destroy every bunker. Airborne troops couldn't carry heavy equipment. The mathematics were brutally simple. Every minute troops spent exposed on beaches, casualties increased exponentially. Yet crossing those beaches with existing equipment required 10, 20, sometimes 30 minutes of pure exposure. But what they didn't know was that one officer had already been thinking about these exact problems for over 3 years.
Percy Hobart was everything the British military establishment feared in an officer: innovative, blunt, and completely unwilling to respect conventional wisdom. Born in 1885, Hobart had revolutionized British tank doctrine in the 1930s. As commander of the Tank Brigade, he pioneered combined arms tactics, coordinating tanks, infantry, and aircraft in ways that foreshadowed modern mechanized warfare. German General Heinz Guderian later admitted studying Hobart's exercises when developing blitzkrieg tactics. But Hobart had a fatal flaw by military standards. He was right too often and said so too loudly. By 1940, his criticism of outdated tank designs and tactics had made him so unpopular with superiors that he was forced into retirement. At age 55, one of Britain's most brilliant military minds found himself serving as a corporal in the Home Guard, directing traffic in small English villages. Then, Winston Churchill intervened. Churchill had followed Hobart's career and recognized genius when he saw it. In a direct memo to the Secretary of State for War, Churchill wrote, "I am not at all impressed by the prejudices against him. Such prejudices attach frequently to persons of strong personality and original view." Hobart was recalled and given command of the 79th Armored Division in March 1933. His mission was unprecedented: develop specialized armored vehicles capable of solving every beach assault problem identified at Dieppe. Other divisions trained to fight. The 79th Armored Division trained to engineer. Hobart assembled a team of military engineers, tank designers, and even civilian inventors. He gave them complete freedom to experiment, with only one rule: solutions must be practical, deployable, and effective under combat conditions. No theoretical designs, no weapons that required perfect conditions. The real breakthrough came when Hobart realized traditional tank design philosophy was fundamentally wrong for beach assaults. Everyone else asked, how do we make tanks better at what tanks do? Hobart asked, what do beaches need, and could we make tanks do that instead? This simple shift in thinking unlocked solutions nobody else had imagined.
The first problem seemed impossible by definition. How do you get 30-ton steel boxes across deep water? Traditional thinking said you couldn't. Tanks loaded onto landing craft which ferried them close to shore. But landing craft were vulnerable, slow, and arrived in predictable patterns. German gunners targeted them mercilessly. Hungarian-born engineer Nicholas Straussler had a radical idea: make the tanks themselves float. The DD Sherman, DD stood for Duplex-Drive, wasn't actually a swimming tank. It was a brilliant illusion created through engineering physics. Here's how it worked. A collapsible canvas screen attached to the tank's hull, held rigid by 36 inflatable rubber tubes. When inflated, this screen extended upward and outward, creating a boat-like shape around the tank. The canvas displaced enough water to provide buoyancy for the entire vehicle. The tank's engine powered two propellers mounted at the rear through a power takeoff system. Maximum water speed 6 knots, slow but adequate. The engineering challenges were immense. The canvas screen had to withstand wave action without tearing. The rubber tubes needed to inflate reliably, even when wet. The propeller system required a separate drive shaft that could engage and disengage. And crews needed to operate everything while mostly blind. The driver navigated using a periscope while sitting inside what was essentially a floating canvas bag. Launch procedures required precision. Landing craft released DD Shermans approximately 5,000 yards from shore, far enough to avoid German artillery, close enough that crews could navigate to beaches. Crews inflated screens in under 15 minutes using compressed air bottles. Once in water, the tank commander stood on the hull, giving navigation directions while the driver followed compass bearings. The system wasn't perfect. Rough seas collapsed screens. Navigation errors sent tanks off course. Mechanical failures stranded vehicles in deep water. On Omaha Beach, 27 of 32 DD Shermans launched in rough conditions sank, drowning their crews. But on calmer beaches, DD Shermans arrived ahead of landing craft, providing covering fire before infantry even landed. German defenders reported shock at seeing tanks emerge from the ocean, psychological impact that disrupted defensive responses. However, the biggest challenge was still ahead. Swimming tanks solved the water problem, but beaches themselves presented obstacles that would stop even D.D. Sherman's cold.
Landmines represented a different kind of engineering nightmare. German defensive doctrine at Normandy called for dense minefields, up to 5,000 mines per mile of beach. Teller mines powerful enough to destroy tank tracks. S-mines that launched into the air before exploding, shredding infantry. Wooden-cased mines invisible to metal detectors. Combat engineers traditionally cleared mines manually using prodding rods and mine detectors. On open beaches under fire, this method guaranteed massive casualties. Hobart's solution was violently simple: beat the ground until mines exploded. The Sherman Crab mounted a rotating drum on the front of the tank, powered by a separate engine. Attached to this drum were 43 chains, each tipped with heavy steel balls. The drum rotated at 140 revolutions per minute, causing chains to thresh the ground in front of the tank. The physics were straightforward but effective. Steel balls struck the ground with enough force to detonate pressure-activated mines. The tank itself remained far enough behind the flail that mine explosions couldn't damage it. A cleared path, approximately 10 feet wide, marked safe passage for following vehicles and infantry. Engineering the Crab required solving multiple technical problems. The flail drum needed independent power. If it used the tank's main engine, losing the flail would immobilize the entire vehicle. The chain assembly had to be robust enough to withstand mine explosions, yet replaceable in field conditions. The system needed to work in sand, mud, and shingle without jamming. Designers created a modular mounting system. If German fire destroyed the flail assembly, crews could jettison it in minutes and operate as a standard combat tank. Extra chain segments stored on the hull allowed battlefield repairs. Operational doctrine called for crabs to advance in line formation, clearing parallel lanes through minefields. Following tanks marked cleared paths with colored flags or ground markers. Infantry followed in the tracks, knowing each step was verified safe. The psychological effect on German defenders was significant. The sight and sound of flail tanks, chains creating massive dust clouds while mines detonated in continuous explosions, suggested overwhelming force. Defenders reported feeling helpless as their carefully laid minefields vanished in minutes. But minefields were only one obstacle. German engineers had created bunkers specifically designed to resist conventional tank fire. These fortifications needed a completely different solution.
German coastal bunkers represented the apex of defensive engineering. Concrete walls 6 feet thick, interlocking fields of fire, gun ports barely large enough for weapons to protrude, artillery-resistant construction designed to withstand naval bombardment. Standard tank guns firing armor-piercing shells simply ricocheted off. High explosive rounds lacked the mass to breach concrete. Engineers attempting to place explosive charges manually became casualties within seconds. The AVRE, Armored Vehicle Royal Engineers, mounted one of the strangest weapons ever fitted to a tank, the petard spigot mortar. This wasn't a conventional cannon. The petard was a muzzle-loaded mortar that fired a projectile called the flying dustbin, and the nickname was earned. The flying dustbin weighed 40 pounds and consisted of a high explosive charge packed into a cylindrical casing. The weapon looked exactly like a trash can with fins. Range was only 80 yards, meaning AVREs needed to close to point-blank distance. But the explosive force was devastating, equivalent to 26 pounds of TNT delivered with pinpoint accuracy. Loading procedures required courage bordering on insanity. A crew member had to exit through the top hatch, stand on the tank's hull while under fire, and manually load the 40-pound projectile into the mortar.
all while German machine guns searched for targets. The petard fired using a spigot system rather than traditional propellant. A steel rod extended from the mortar into a cavity in the projectile. When fired, the explosive charge propelled the projectile forward, while the spigot provided stability. This system generated less recoil than conventional guns, allowing the weapon to be fitted to modified tank chassis. Impact against concrete bunkers created catastrophic results. The flying dustbin's flat trajectory meant it struck walls perpendicularly, maximizing energy transfer. Even if the round didn't penetrate, the concussive force stunned defenders inside and often collapsed internal structures. AVREs carried additional engineering equipment. Fascines, massive bundles of wooden logs that tanks could drop into anti-tank ditches, creating instant bridges. Bangalore torpedoes for breaching wire obstacles. Smoke generators for concealment. Some AVREs towed bobbin carpet layers, devices that unrolled canvas and metal track across soft sand, creating temporary roads. But what they didn't know was that Hobart's team had developed even more specialized variants for specific obstacles.
Hobart's engineers created solutions for every beach obstacle encountered in intelligence reports and reconnaissance photos. The Churchill crocodile addressed pillboxes and trench systems. This variant replaced the tank's Hall machine gun with a flamethrower capable of projecting burning fuel 120 yards. A 6-ton armored trailer towed behind the tank carried 400 gallons of flame fuel, enough for 81-second bursts. The psychological impact was immediate. German defenders abandoned positions rather than face flame attacks. The Churchill AVRE with SPG bridge solved a specific problem identified at Dieppe. German engineers deliberately created gaps and destroyed bridges to stop vehicle advancement. The small box girder bridge, mounted on modified AVREs, deployed a 30-foot bridge capable of supporting 60-ton loads. Hydraulic systems laid the bridge in 90 seconds without crew exposure. The armored bulldozer Sherman modified standard tanks with engineered bulldozer blades. These vehicles cleared beach obstacles, filled craters, created defensive positions, and pushed disabled vehicles off critical routes. Simple, unsexy, absolutely essential. The Canal Defense Light, one of the strangest devices, mounted a powerful searchlight inside a tank turret. A shutter system created rapid flashing, disorienting defenders and illuminating targets. Few saw combat use, but the concept demonstrated Hobart's willingness to explore any solution. Less known, but equally important, were the armored recovery vehicles. Modified tanks with winches, cranes, and repair equipment. They recovered disabled vehicles under fire, repaired damaged equipment, and kept other funnies operational. Training integration proved as important as the machines themselves. The 79th Armored Division didn't just teach crews how to operate specialized vehicles. They developed combined tactics, coordinating D.D. Shermans, Crabs, AVREs, and crocodiles in sequential operations. Standard beach assault doctrine evolved. D.D. Shermans swim ashore and establish fire support. Crabs clear mine lanes while AVREs follow, removing obstacles. Once paths are clear, standard tanks and infantry advance through verified safe corridors. Crocodiles suppress remaining resistance points. Each vehicle type supported others. Crabs needed AVREs to remove concrete obstacles blocking their path. AVREs needed Crabs to clear mines before they could approach bunkers. D.D. Shermans provided covering fire for both. The entire system functioned as an integrated engineering solution rather than individual weapons. American General Omar Bradley observed Hobart's specialized tanks during pre-invasion demonstrations. He rejected them, believing the devices overcomplicated assault operations.
U.S. forces would rely on superior firepower and troop numbers instead. The real breakthrough came when planners realized these weren't just beach assault vehicles. Many Funnies continued valuable work long after D-Day, supporting operations across Europe.
June 6, 1944. Dawn. On Juno Beach, Canadian forces, supported by Hobart's Funnies, advanced against heavily fortified German positions. D.D. Shermans provided covering fire from the surf. Crabs cleared mine lanes within minutes. AVREs systematically destroyed concrete bunkers that had resisted naval bombardment. Casualties? Moderate, but manageable. Beach secured by noon. On Sword Beach, British forces employed the full range of specialized armor. Crocodiles cleared trench systems. AVREs bridged anti-tank ditches. Within hours, armor pushed inland toward calm. Casualties? Lighter than predicted. Objectives achieved ahead of schedule. On Gold Beach, coordinated use of Funnies allowed rapid penetration of coastal defenses. By day's end, British forces had advanced 6 miles inland, the deepest penetration of any beach on D-Day. Then there was Omaha Beach. American forces landed with standard equipment. No D.D. Shermans deployed in rough seas. No Crabs to clear mines. No AVREs to breach bunkers. Combat engineers worked manually under devastating fire. The result was catastrophic. Nearly 2,500 American casualties on Omaha Beach alone, more than all other beaches combined. Troops pinned down for hours. Objectives not secured until late afternoon. Some units suffered 90% casualties. Military historians have debated for decades whether Hobart's Funnies would have made a difference at Omaha. The answer appears in the numbers. British and Canadian beaches employed specialized armor and achieved objectives with roughly 1/3 the casualties of Omaha Beach. Post-action reports from German defenders provide additional evidence. POW interviews revealed that specialized armor created confusion and panic. Defenders described feeling helpless as their prepared defenses, minefields, obstacles, bunkers, were systematically neutralized by machines they'd never encountered. German defensive doctrine assumed Allied forces would require hours to breach beach obstacles using manual methods. Hobart's Funnies compressed that timeline to minutes, fundamentally breaking the defensive strategy. However, the biggest challenge was still ahead for these remarkable machines.
The Funnies didn't retire after D-Day. Many served throughout the European campaign, adapting to new challenges. During the Battle of the Scheldt in October 1944, AVREs and crocodiles proved essential for clearing flooded polderland and fortified positions. The specialized armor allowed Allied forces to overcome terrain that favored defenders. In the Rhine crossing of March 1945, AVRE bridge layers became critical. German engineers had destroyed every bridge across the Rhine. Churchill AVREs laid temporary bridges under fire, allowing armor to cross before engineers could construct permanent spans. Crab flail tanks continued mine-clearing operations throughout Germany. The German retreat included extensive mining of roads, fields, and towns. Crabs cleared routes faster and safer than manual methods. Several Funnies saw service after World War II. Flail tanks cleared mines in Korea. The concept of specialized combat engineer vehicles influenced every major military. Modern militaries operate direct descendants, armored bridging vehicles, mine plows, and assault breaching systems all trace lineage to Hobart's innovations. The engineering principles proved more valuable than the specific machines. Hobart demonstrated that specialized equipment designed for specific problems outperformed generalized weapons. This insight transformed military engineering doctrine.
Percy Hobart's fundamental insight remains relevant today. Sometimes the solution to an impossible problem isn't doing the same thing better. It's asking what the problem actually requires and designing completely new approaches. Modern militaries operate specialized engineer vehicles directly descended from Hobart's Funnies. The M1 assault breacher vehicle, employed by the U.S. Marine Corps, uses a line charge system to clear mines and a bulldozer blade to remove obstacles, combining multiple Funnies concepts into a single platform. Israeli Defense Forces developed the IDF Puma, a heavily armored engineering vehicle based on Centurion tank chassis. It carries combat engineers, breaching equipment, and mine-clearing systems. The design philosophy mirrors Hobart's approach: integrate engineering solutions with armored protection. British forces still operate Trojan armored engineer vehicles and Titan armored bridge layers, direct conceptual descendants of Churchill AVREs with fascines and SBG bridges. The engineering lesson extends beyond military applications. Hobart's method, identify the specific problem, design equipment to solve that exact problem, integrate solutions into coordinated systems, applies to any complex challenge. He didn't ask, how do we make tanks more powerful? He asked, what prevents beach assaults from succeeding? Each identified problem received a tailored engineering solution. The integration of multiple specialized systems created capabilities far exceeding what any single weapon could achieve. Perhaps most importantly, Hobart proved that unconventional thinking requires institutional support. Without Churchill's intervention, these innovations would never have developed. Bureaucratic resistance to unusual ideas nearly cost the Allies their most effective beach assault technology. The story of Hobart's Funnies reminds us that breakthrough innovations often come from asking different questions rather than finding better answers to existing questions. And sometimes the most practical solution looks absolutely ridiculous until the moment it saves thousands of lives. If you found this deep dive into military engineering fascinating, hit that subscribe button. Next time, we're exploring how American codebreakers cracked the Japanese purple cipher machine, not through mathematical genius alone, but through a stolen piece of information nobody realized was valuable. The story involves a drunk diplomat, a copied document, and an engineering breakthrough that changed the Pacific War. What other bizarre military engineering solutions should we cover? Drop your suggestions in the comments, and if you know someone who loves engineering and history, share this video. These stories deserve to be remembered.